Hello, everyone. Thank you for joining us today. My name is Emily Kuda, and I'm Percona's Digital Marketing Manager. We'll get started in just a moment, but first I just want to conduct a bit of housekeeping. Can you raise your hand to let me know that you can hear me? Awesome. Thank you so much. Next, during this webinar, you will be on mute. If you have any questions, go ahead and enter them in the questions field down below. And any questions that we couldn't answer will be answered in a follow-up blog entry. I'd like to thank you for attending today's webinar, Demystifying Postgres Logical Replication, presented by Percona's Senior Technical Services Engineer, Emmanuel Calvo. With that said, I'll turn the floor over to Emmanuel.
Hi, thanks, Emily, for the introduction. Okay, the talk for today is a very brief introduction for the logical replication feature that will be added in the next Postgres release, which is the Postgres 10 version. A bit of myself. I'm known as a 3maniac. My site is 3maniac.com. I'm currently working as a remote DBA for Percona. I worked for several companies in the past, some MySQL specific, some others Postgres specific. And okay, so before talk about the logical replication, we need to understand how we reach this step from previous Postgres versions. The replication was added as a streaming replication in 9.0 and has been improved on the subsequent releases. The streaming replication is basically how you do mirroring between a master and a slave, and we are going to talk about more in deep in the next slides. And this feature is part. It's a set of features that allows to do this, and the main feature that logical replication relies in is the logical decoding that was added in 9.4, and I'm going to explain on why this is important to know. Okay, so basically the streaming replication, it's a byte-by-byte replication, and the whole instance, which means all the databases, are replicated in a very consistent manner. Every block that is written in the wall or the checkpoint segments are sent to the slaves. It's the best way to maintain a consistent slave for file operating. The logical replication is supported through Visual Logical for 9.4, and I'm going to explain how can you achieve this, but basically it's related to the logical decoding feature that I spoke in the previous slide. And okay, so logical replication will be natively supported in the next Postgres release, and you won't need any third-party tools to reach a Postgres a logical replication. So for people that come from MySQL, that I assume that if you hear about Percona is because you've been playing with MySQL. But basically, is the logical replication is very similar on how the MySQL replication works, with several important differences, but the key concept is actually the same. Suppose that you have InnoDB and you have the log files from InnoDB that are the recovery files for when your database goes down and needs to start up. And all these events are translated into the binary log. which is streamed to the slaves. Simplistically, I'm talking. And well, Postgres is actually the same. We have what it's called the write-ahead log, which is the files used for restoring a database in case of failure or in case of an issue. And these entries are translated into a specific logical log, which is done by this logical decoding feature. And then those changes are sent through specific workers to the slaves. The key difference between both is that the filtering is done in the master instead of on the slaves. And basically, this is possible because when you set up a logical replication publication, you can set the tables and the events that you want to stream out to the slaves. So what are the capabilities of the feature? This feature is intended to be cross-version, so it's intended to be used for example, upgrades or migrations, or or scaling out specific tables inside the database. It's more flexible than the student replication, as it is not a migrating system, so it allows you to stream out in a flexible way. One of the most important things is that as it does not sense every change on the database, it has less write amplification than stream replication over the network. It only sends to the slaves in commit order the changes, and this is a very important thing if you already have, for example, one master and 5 slaves. Maybe in the past you've been seeing issues with slave lags when doing vacuum on the master. This is very a common issue, as the write-ahead log is being receiving all the changes from the vacuum, and those are sent to the slaves also. So this generates a lot of write amplification over the network. With logical replication, you avoid this. So this is one of the key things that makes this feature very interesting for learn about. And the publications and subscriptions can connect each other to several sources and destinations. What you can do with logical replication, well, the same that as you've been doing with MySQL replication, but I can say that it's a bit more flexible. For example, you can replicate to the slaves for append only events, and remove data on the master to keep different retention policies between the master and the slave. This is pretty interesting. I wrote a blog post a few months ago about explaining on how you can achieve have one partition in the master with, I don't know, 3 months of data, and slaves with more data than the master doing event filtering by not replicating the delete event over certain tables. It will be a very usable feature in case that you had too much issues with stream replication. Although I won't recommend to use logical replication for having migrating, but in certain cases, whether you want to have very read slaves for just querying, and maybe it's a good option for spinning up faster sets. You don't need to replicate the entire cluster. You can replicate just the smaller sets, and that makes this feature more willable for doing for setting up new slaves for read on specific sets. You can do multi-source replication, or for consolidation into reporting servers. You can actually distribute the data over a shard. And I'm going to show also one of the things that you can do manually for doing sharding with this. You can do more flexible replication chains, which allows you to make more complex data architecture, database architecture. So it's interesting about this. I can show you some examples. To do data transformation, as you can replicate to destination server, and also this destination server can be a source for another server. You can do data transformation in the middle. You can replicate a table, do some process, and publish into another table. The limitations are quite a few, but the most obvious one is that you can't stream over the same host. I'm not sure if this is is intended to be, but it has sense that it doesn't avoids to enter a cycle of replicating into itself. The tables and the columns that you want to replicate must have the full qualified name, which means that you can have different, at least at the moment, but probably in the next versions, this will be added. But the tables and columns must have the same name, and the columns must have the same data type. Although the slaves can have more columns. If you can have a table on the master that replicates to the slave, but the slave can have 3 or 4 columns, additional columns. This can be useful for doing transformation or other processes that you may need to have additional columns on the slaves. Also, you can have different indexes. This is even more interesting for data transformation, that you can have, for example, replicated to a slave, and the slave can have more specific indexes for, I don't know, block range indexes for doing range scans over certain certain range of data faster, and doing like small sequential scans over the table instead of massive sequential scans. Or you can have guest or gene indexes also. The subscriptions, okay, so the database super user is needed for the publication and subscription creation, so you will need a super user. This is interesting because we are going to see how it will be added on the next RDS versions, as they do not provide super user. Okay, the elements of the logical replication are basically 5. And I say 5 because I'm considering the replication slots and the output plugin as part of the logical decoding. And I'm going to go through each of them. So the logical replication slots, or the replication slots, it's a table, but actually it's a table for the user, but it allows the server to track which was the last log sequence number replicated. So it's a way to track the replication for the slaves. There is a ton of things to talk about replication slots. It's people that is new in Postgres tend to misunderstand the replication slots, but basically what it does, it's keeping track of the last log sequence number, but also it allows the master to know which checkpoint segments can be archived or not. So it's a feature that you need to understand how to play with it. Otherwise, you can have certain issues with disk space. But basically, it's a cleaner way to maintain your write-ahead logs, as you can configure replication slots to have consistent slaves, and in case that one slave goes down and needs to get the changes from the master won't remove the checkpoint segments until they are shipped to the slaves. And the most important thing to understand is that slots are placed in the origin, because the slaves will connect and will use these slots. The logical replication slots, the small difference between the replication slots and the logical replication slots, it's just a few columns, but the functionality is actually the same. The only thing that you will see interesting on this table as a difference is the plugin. The plugin, you will see the PC output plugin, and the PC output, it's the plugin that translates from WAL records to Postgres style records. The logical decoding allows you to use several plugins. We have the test decoding plugin, which is the default that comes for testing. But you can use a ton of plugins in logical decoding. For replicate to, there are plugins for replicate to MySQL, plugins to replicate to Oracle and whatever. And this is going to, the community will continue adding more plugins for the logical decoding. So this is an example. Oh, sorry. This is an example of how logical replication slots work. So this GIF will show you how to create a replication slot using the test decoding plugin, which is the testing one. This is going to show you the snapshot of the replication slot. Means that the snapshot means that the right time, the photo of the transactions committed and of the entire cluster. Now we are querying the replication slots. You will see that I'm just querying the PC replication slots catalog table. And now what I'm going to do is to start to add data. I create a table. I'm going to add some data. And now I'm going to do a pick. There are two actions that you can do against a replication slot. One is pick changes, or the other is get changes. The difference between both is that the pick changes will show you the events since the last flush log sequence number that you have in the replication slot, and will show you all the events. But it won't consume those events, meaning that if you execute again big changes, you will continue getting incrementally all the changes that you have. And I'm going to, actually, I'm doing the same. I'm showing that I'm still picking the changes and I'm seeing the same events. And now what I'm going to do is I'm going to get the changes. So get changes will do the same, but this time it will update the replication slot. So it will consume all those events and will confirm to the master. And next time I do a get change, you don't get nothing, or you will get the new the new changes. Basically, you will see that it's a particular column here, which is the transaction ID, which is the commit order as a commit order sequential number. And it's very easy to understand if you look at the, it's very self-explanatory how it works, basically. So the output plugin is the same as the test decoding, but it's a bit more complex. But actually, what the output plugin, it's test decoding. It's an output plugin, and the plugin for the logical replication is the PC output. The exported snapshot. This is another feature that is used for when doing the initial copy of the data. This feature allows you to start the transaction, export its snapshot, and in the meantime that this transaction is running, you can import the snapshot from another transaction and have the same visibility as the original transaction. This is very useful if you have like very long transactions and you want to trace these transactions by seeing what is seeing the transaction inside. It's an interesting feature, and in the case of logical replication is used for when doing the initial copy of the data. So it can spin up different transactions or several transactions to start to stream the data. One of the key elements is the publication. Publications are just the definition of which tables and which events do you want to replicate out. And the publication is created, obviously, in the origin server. And there is a particular statement here that the tables needs to be declared with the replica identity. The replica identity is the way, which index or which, not index, but which constraint you will use to detect conflict in the slaves. The only parameter that you have for publications is the published string, and it's just a text string which has insert, update, delete. You can just put insert, you can just put delete, but or whatever you want. But this has changed. If you saw my previous presentation at ProCon Live, the statements were totally different because I was using the alpha version, and the beta version released some important changes on the syntax of the command. The other element is the subscription. The subscriptions are more interesting because they do have more factors that you need to be aware of. But basically, when you created a subscription, you can reuse a replication slot from the origin, or as by default, it will create a new replication slot. So this means that at the moment you create the subscription, you will write on the master this replication slot, and it will start to stream the data using this replication slot on the origin. And actually, you will reuse this replication slot for re-snapshotting the set, the replica set on the slaves. One key important thing is that the DDL is not replicated, so you must create your tables before create the subscription. This is very important because otherwise it will not replicate nothing into the table. The session replication rule is just set for avoiding circular, for avoiding recursive replication. The other is that when you create a subscription, it will use a specific slot name. It will use the subscription name. This is sometimes you must be aware of this, because if you remove the subscription on the slave, but you don't remove the slot on the master, it should be removing the slot by default. But if you want to recreate the subscription using the same name, it can fail as the slot already exists, and by default the subscription will try to recreate the slot on the master. I mean the origin. I don't want to say master in this case, because logical replication it's more about it works more like a queue system, with publishing and subscribers that are consuming events over a queue that it's on the master. It's a closer analogy rather than master and slave. And one important thing is that the slaves will continue to be writable. So you can stream out the slave to the master, to the origin, in bidirectional way. The subscription can be altered, and one thing that you can do is one of the actions that you can do is refreshing a subscription for getting the data again, or also you can add another publication. So one subscription can feed from different sources. So this is even more interesting, because you can, in one origin, you can have, for example, 3 publications, and 2 are going to one destination, and 2 other can go to another. So you can have a very flexible replication schema. There is a particular, I don't know if it's a bug or it's an expected feature, that if you have a destination, and if you remove a row on the destination and do a refresh, it will keep the row deleted. And I assume that it could be a problem because this replication system use a track timestamps for committing the data. And the only option for the subscription in this case is the refresh option and the copy data. By default, it's true, so it will copy over the data by default. And you can control this the synchronous commit variable here, which means which level of consistency do you want to have for this replication set. So it allows you to control this. Generally, I will say that if you use logical replication, don't try to go like full consistent, because generally logical replication will be very useful, but for having a file over server, I will always recommend to use a stream replication. Okay, so this is one example, a very brief example of how you can use a publication. The first example has a set of tables that are replicated to, oh, let's see if I can see the pointer. And then you can create your own DDL triggers to get the table structure for created on the destination servers. Which is called the event triggers. The other is that, for example, you can just grab one table and only one and apply a filtering on the events. And also there is another feature on Postgres coming in the next release, which is the partitioning. I'm going to show an example in the next slides that contains more information about how this works. But basically, you can stream out a single partition of the database. The basic definition is this one. This is a publication over a single table and only replicating the inserts and updates. This was specifically for showing how you can have different retention policies between the origin and the on the destination servers. And you can see here that when you create a subscription, you can tell if you want to reuse a specific slot from the origin, or if you want to create a new one, and if you want to copy the data. By default, it will stream everything out from the origin. For example, this slide shows you how to create a subscription and alter the subscription for adding an additional publication to it, and how you can refresh the subscription. All of this I'm going to show in the terminal. The flow of the data, it seems like quite complex, but actually it's pretty easy to understand if you understand how logical decoding works. Basically, the logical decoding is in charge to translate the WAL records in commit order into a logical output, a logical files, and there is a worker in charge of streaming this from the origin to the slave, which is it will be called WAL sender process. Can be confused because the WAL sender also is for streaming replication, but in this particular case, the WAL sender sends the logical changes. In the origin, there is an additional background worker, which is the logical replication launcher, that is just an agent that detects whether you create a publication and whether a slave is trying to fetch data from the origin. And so this is just spin up workers for streaming out the origin. It does not stream nothing. It just wakes new processes on the origin. On the subscription side, we only will have the logical replication worker for subscription, which does what it says. It just takes the changes from the WAL sender and applies them to the WAL, and that's it. That's how it works. There is no other thing on the subscription side. As you can see, the application can write both on the origin and the destination server, and that is the reason why I don't want to call them master slave, because in this particular case, it's like streaming logical rows. So you can do in the other way. You know, this one of the servers that has subscriptions for one other for streaming in from another server can have publication for streaming out to other server. So it's not strictly a slave, because it can receive writes, and actually it can receive writes on the same table if you want, which is not very recommendable at some point, but it can. Any violation in constraints stop the replication. I will generally, if you, for example, do an insertion of a row in the destination that, for example, a primary key, I don't know, 10, and then you want, and then this a row with this same ID comes into the destination, replication will fail. But if you can fix this manually, if you remove the row from the slave, automatically Postgres will retry constantly to replicate. So if you just remove the row, or if you remove the conflict, the replication will flow again. You don't need to start, to stop, or do anything else. One important thing is that updates and delete operations on data that is missing on the destination will silently fail, which means that it won't complete nothing. So this is important to know. There is a particular function that allows you to skip an event, like, you know, as now as in MySQL we have previously the SQL skip counter. The only problem that I saw here is that the position is done through log sequence number, and to get the log sequence number for a particular position, it's a bit harder. So what you can do is you can check the replication slot and issuing peak changes. Do not get changes, otherwise you will get into worse issues. But or with third-party tools for viewing the wild record contents. This is the other way. There is a particular view that allows you to like in a show slave status, basically, but this the origin status at the subscriber that allows you to follow and see what has been streaming from the origin. The replicate entity is how you define a table. And you can say, okay, I do want to use this particular index as a replicate identity, or just the default, which is the primary key. For monitoring the logical replication, you can just query the PC replication slots on the publisher. And in the subscribers, you have more tools for doing this. For example, this is not very probably self-explanatory, but what I'm doing in the first query for the subscriber is to get which origin do I want to monitor. Unfortunately, there is no way to to have a more explicit name for the origin server. But if you have a few of them, you can track them and, each time you add one. Okay. And then I use the PC replication origin progress function, which just take the name of the name of the origin and outputs the current progress. What other things are okay? The PC replication origin status is the same view that I spoke before. And the subscribers, for example, in this case, you can check the status of a particular subscription. This is the view that cares, because here you see what has been received, what has been applied, and etc. And more importantly, if you want to monitor a single process from the operating system, you can know the PID of the process and monitor it to see if it's consuming or not, and the latest time that a record has been written. The minimum configuration. There are several variables that you need to be aware of, especially because, as I said in the first slides, logical replication is not a single feature. It's a feature that uses a set of features, and it uses the logical decoding and the plugin for translate the rows into logical rows. But also there is another one that I didn't mention, is the background workers. Background workers are custom developed processes that run inside the Postgres, inside the Postgres ecosystem. It's a child of the Postgres main process. So you can develop your own background worker and to do very specific things, whatever you want inside the database, using a framework for this. And so this is another of the features, other feature that logical replication uses. Knowing this, I can explain what the variables do. The while level needs to be logical. This is the maximum level of while level. These three states are the new states in Postgres 10. It can be minimal, replica, or logical. Replica is for stream replication, and you need to have this set as logical for allowing logical replication. The max world senders, as I said, you can have world senders for streaming replication, but also you can have world senders for logical replication. So you must be aware of this variable if you want to set, let's say, more than 10 as default. The one keep segments, it was one of the variables that was used to say to the master of the stream replication how many checkpoint segments should be kept for if one slave goes down and needs to synchronize with the master. If you use slots for stream replication, you don't need the while keep segments, because the master will know if the checkpoint segment can be archived or not by checking the replication slots. So this variable, it won't be used. In the case of logical replication, we always use replication slot, so we shouldn't need this variable, and it won't be needed. The maximum replication slot by default is 10. You can increase as you please depending on your needs. And the max worker processes, this is one of the things that I mentioned. about the background workers is that you can put a limit. But if you have your own custom background workers, or if you use another features that use background workers, be aware that you may need to add more worker processes in the configuration. For the subscribers, you have other variables that can you can limit the amount of replication workers on the subscriber. You can how many workers for synchronization you want to have for each subscription. By default is 2. If you have like pretty massive data sets and you have enough cores and bandwidth for streaming more, you can push more. Hopefully in the next versions, probably it can be set by subscription. And also you have the max logical replication workers, which is already mentioned. The related functions, okay, this is just for logical decoding. I don't want to dig too much in this slide because it's more related to logical decoding. For logical replication, you won't need them. This is for if you are a developer that wants to develop a Postgres-based system for consuming changes, you need to be aware of this. But otherwise, for logical replication, it's not very interesting. Okay, we have only 10 minutes more. Partitions is a new feature in Postgres 10. For people that use Postgres before, Postgres had the feature of inheritance, meaning that you can inherit from a parent table and with triggers doing a manual partitioning. For Postgres 10, Postgres supports partitioning now, and it's totally different from the concept of the inheritance. So it's not something built on top of this feature. It's a totally different feature. They have their own specific things, the partitions, and it has its own syntax for creating partitions and detaching and attaching partitions. But also, if you go to the link of the title, you will go to one of my articles that explain how to do this. But actually, this slide is showing that you can have servers with partitions and stream one partition to another, and from the destination stream another partition to the origin. So you can basically do a manual sharding using partitions and with minimal bandwidth needs. And basically, it's a very interesting approach, and it allows you to build a very interesting system with nothing more than just the native features of Postgres 10. As I mentioned, logical decoding is supported since 9.4, and Visual Logical is a third-party tool developed by Second Quadrant that basically uses the logical decoding to do logical replication in versions that do not support natively. But also, Visual Logical has more flexibility. It allows you to do role filtering with the value. For example, you can filter by specific IDs or etc. So it's still a bit more flexible than the native feature. And if you have a Postgres 9.4 and above, you know that you have a way to do logical replication, even if it's not natively supported. And the other constraints and um, uh, characteristics are pretty much the same with logical replication. The commit order is preserved, and the key concept of how it uses logical decoding is basically the same. Another tool that is built on top of logical decoding and that use a similar concept of logical replication is BDR, which is bidirectional replication. It allows you to have it's a multi-master system with conflict detection and selective replication. Right now, it's a fork of 9.4, but it's being worked to be an extension in 9.6. And basically, it uses the logical decoding in logical format to replicate asynchronously between two endpoints. RDAS also supports the logical replication using the task decoding feature. I didn't try it yet, but it's functional, it's documented. So if you have time and you're willing to try it on Amazon, go ahead, you can use it. This is some reference links if you want to get more deep into. And well, I have I will try to show you in 5 minutes some showcases of how the logical replication can be fixed and a set of publication with many subscribers. So I will see if I share my terminal.
Nothing yet on my end.
Yes, I'm trying to share the terminal, but I'm not seeing the option for select the terminal. Any questions so far?
Yeah. One of our questions while we wait is what does the logical log contain, the SQL statement?
Sorry?
What does the logical log contain, the SQL statement?
Yes. Yeah. Well, it's an internal format, but basically it contains a translated a translated string from the world record. It's not a SQL itself, and it can't be accessed manually from the operating system. It can be accessed through Postgres processes only. But it's not that you can grab the SQL statements from the log. But basically, it's a translated from the world record, but doesn't mean that you will have the string of the SQL inserted. I mean, written on the logs.
Looks like we can see the terminal now.
Yes, I'm can you see the terminal?
Yes.
So that's the point. Any other questions?
Yeah.
I don't see the questions on the
Oh, that's okay. I'll
on
read them
the
too.
web. Okay,
Is master not possible?
it is. The problem with this is how you do the identity. And actually, the BDR uses the same technology, the same features to achieve the same. The only thing that you need to be aware of this is that this is an asynchronous way to replicate, and there is no conflict detection if you use logical replication, but you can stream bidirectionally. And actually, the example of doing replicating partitions to one origin to a destination and vice versa, it's basically a master. You can, but yeah, you can do it. I won't recommend to use logical replication specifically for writing in the same table. But what you can do is to have different replica sets and replicate one using one server as master of one replica set and the other server as a master of another. The replica sets can be set. When you create the publication, you can say, okay, create a publication for all the tables on this database, and that's it. So you are replicating the entire database. Just be aware that when I say database in Postgres, the concept of database is different from the MySQL. Databases are isolated each other. So when you create a publication, it's at database level. So if you create a publication for all the tables, will be only from of the database, not the entire cluster of database of the server.
Okay. We are getting close to the top of the hour. Did you want to stay on a little bit longer to show the terminal? I don't mind.
Yeah, it will be okay. There is not the examples do not take that much, so it will be pretty much fast. Okay, so those examples have been were made for alpha version. So you will see probably some difference on the syntax, but the concept is the same. So I'm going to show, for example, okay. Okay, so this example will show how I achieve a setup of a publication and start to write on the slave, and then I break the slave when I break the destination server. So I created the database, created a table with a primary key. I created the publication for that table. At this point, nothing has been replicated. Just we have in the origin, we have the publication ready to stream out. Now I'm going to start to create the subscription on the destination server. I created the table already on the, okay, in this case, I didn't create the table yet. Here I'm showing, I removed the slot because I didn't have the slot on the origin from a previous example. Now I created the table on the subscription. Now the subscription can be created and the data has been synchronized. So far, since now, the changes that I apply on the origin, they will flow to the subscription. And now I break the destination server. I just inserted a row with a value that did not exist on the origin. So now I'm going to add this. I write this statement on the origin, and now we will see that the destination will start to complain about, hey, this key already exists, and that the worker that does the logical replication apply exits with an error. With this, I'm checking which is the status. You can see there is a difference between the confirmed flush log sequence number and the local sequence number. So that, unfortunately, is not very nicer to follow these numbers, but you can see there is a difference between one another. And to fix this, I just deleted the row, and the logical worker continued working. So I did not do anything else rather than just removing the culprit row. And the other example shows, I have two examples. One is a possible bug, and this one is how you can have different subscriptions to a single publication. This is a very interesting case. If you, for example, have you want to have you receive like a massive amount of events from a specific log, and you are writing them into a single node, but then you want them to be streamed out to a destination server, to a replica of that set. But also you want to be sure that you have always a secondary subscription that get those changes. So the only problem with this is that there is a race condition that only one subscriber will get the changes. But at the time that one of the subscribers goes down, the other will continue feeding the changes. So this could be useful if you, for example, just need to do very specific time series data analysis. So you can stream in to one subscriber, and then you can pause the subscription on that subscriber to let the other continue feeding the data. So you can, manage the load between streaming data in and doing processes. So you can have like feeding in data and doing different processes in different servers that have different subscriptions, but always pointing to just one single publication. Obviously, this is not for failover, because you will have different data on the subscriptions, but it's still useful if you have like a serious amount of incoming data and you want to process them by splitting the subscriptions. And the other example is a bit more, I need to check if this is a bug or this is an expected feature. But it's interesting to see because this one has the new syntax of the Postgres 10. So the example will just show how to create a publication subscription, and then how to refresh the subscription node to get the changes again. This is just create tables, and then I do just some inserts. Let's go to see what data do we have. Okay, we have two tables, Q1 and Q2. Sorry, I wasn't very original with the names and with the data itself. I created two separated publications, one per each table. Remember that you can create a publication for several tables. It's just for, I just created one per publications just to be, oh. Can you hear me? Because it seems I lost the connection.
Nope, we can still hear you just fine.
Okay.
Were there any more?
It appeared a pop-up.
Okay.
So now I created the subscription on the destination server. And now I can see the queues. I'll see that the Q2 has not been added to the subscription yet. You will see that the publication only gets from one of the subscription is getting the changes only from one publication. Now I'm adding the other publication. And I copy the data over again. So you will see now the Q2 also on the destination server with data. And the bag is basically that, again, the pop-up up here. I'm going to remove one of the rows of the subscriber table, and then I'm going to update the row on the origin to force to send the event through the logical replication. And you will see that when I refresh the subscriber node, it won't get that row. So this is probably related with the timestamp because the logical replication is using timestamp for committing the rows. So this is probably related with this. So I will need to check if this is a expected bag or it's not an expected. But the way to solve this is to recreate the subscription instead of altering it, because you will need to get a different snapshot on the origin to stream in. And see that I refreshed the publication, but the row with ID 3 still not appear. I tried to force the copy data, but still with the same issue. I truncated the table, but still not seeing the row. So this is probably related to the snapshot used on the replication slot in the origin, and that the change on the subscription is newer from the origin side. But here we go. Yeah, basically it does. It was a showcase that I did for the PC day to show which was a bit more advanced, showing more the internals. But basically, the idea was to show that certain things that you must be aware at the moment for the beta version. That's it. I think I don't have anything else. Thanks for attending. Thanks, Emily, for the help. And any other question?
There was a few, but we're actually over on time. So I'll make sure to send them to you later today, and then hopefully we can get a blog post out shortly.
Awesome. Well, my site, 3manual.com, you can ping me through Percona. If I publish the blog post, you can comment and share experiences and do questions. Generally, I used to be on the Postgres list. I have some time constraint issues, but feel free to ask right away. I will try to publish more of this awesome feature. And thanks for attending.
Thank you so much, everybody.
Bye, everyone.
Bye-bye.